Good morning, students. Today we are going to start a new topic, that is inertia and mass in the subject of physics. This is very important topic, so concentrate yourself. We are going to start. The definition of mass is a scalar quantity that measures the amount of the matter a body contains. The mass depends on number one, the number of the atoms it contains. More the atoms, more will be the mass. Less the atoms, less will be the mass. And the second thing, the size of those atoms. The bigger the size of the atom, the more will be the mass. The lesser the size of the atom, the lesser will be the mass. It is a basic property of the body and cannot be changed by the location, the shape, the speed of the body, for speeds much less than the speed of the light. So it cannot be changed because of these three factors. The SI unit for the mass is kilogram, represented by kg. Larger masses, for example mass of a car, are measured in tons. 1 ton is equal to 1000 kg. While the small masses, for example mass of a pencil, are measured in grams. 1 gram is equal to 1/1000 kg. Here is an exam tip. The number and the composition of the atoms and molecules make up the mass of the body. All unknown values of the masses are measured by comparing them to some known values of the masses standardized against the prototype kilogram, kept at the International Bureau of the Weights and Measures in a town called Sèvres, just outside Paris in France. The prototype kilogram is a small cylinder having its diameter 3.5 centimeter and height approximately equal, made of 90% platinum and 10% iridium. This alloy of very high density is least affected by time and environment. The unknown mass of the body can be found by comparing it to known values of the masses on a common lever balance. The two arms of the balance are equal in length. The chemical balance is an example of a common lever balance. Figure shows the unknown mass of X to be equal to 250 gram or 0.25 kilogram when the balance is in equilibrium. Here is the figure. Mass is put on one pan and on the other pan a known mass is put. When the balance is in equilibrium, the mass is found, that is 0.25 kg. The next topic is inertia. Inertia of a body refers to the tendency of not changing its state of rest or motion. Explanation: a stationary body tends to remain at rest by itself. Such tendency is called inertia. A moving body keeps on moving with the same velocity by itself. Such tendency is also called inertia. Examples of inertia: when a bus stops suddenly, the passengers continue to move forward. They need to hold tight to the handles to overcome the inertia. A fat person can easily lose its balance if he tries to run in a zigzag manner. He needs to adjust his speed to cope with this problem caused by inertia. A bus with a mass of 7,000 kg has a larger inertia than a car with the mass of 1200 kg. As such, the bus needs higher engine power and yet it still accelerates slower than the car. A question related to the last point is, two groups of the people get into two identical cars. One group consists of 5 sumo wrestlers, while the other group consists of 5 marathon runners. Assuming both drivers step on the accelerator with equal force, state and explain a part which car takes off faster from the rest. Definitely, the car which is having 5 marathon runners will takes off faster from the rest because mass of the car is lesser than the mass of the sumo wrestler's car. Because sumo wrestlers are very fatty and marathon runners are thin in the mass. B part is, which car would need a longer braking distance once in motion? Because the car having sumo wrestlers is having more mass, so that car will need a longer braking distance once in motion. Next topic in the lecture is gravitational force and weight. Weight is a vector quantity that measures the amount of the gravitational force acting on a body. All objects are attracted by the gravitational pull of the earth or gravity. This force pulls all objects towards the center of the earth. An object with more mass experiences greater gravitational force acting on it. According to Newton's second law of motion, F is equal to ma. To find this gravitational force known as the weight, simply multiply mass by acceleration due to gravity. W is equal to mg. G is 10 meter per second squared. This is a fixed value. Now we are going to read the differences between mass and weight. Very important topic in paper. Definition of the mass is, mass of an object is the measure of the amount of the matter that it contains. Definition of the weight is, weight of an object is the attractive force exerted on it due to gravity. Mass is a scalar quantity, whereas weight is a vector quantity. SI unit of the mass is kilogram, represented by kg. SI unit of the weight is Newton, represented by capital N. Measurement of the mass is using a beam balance or an electronic balance, whereas measurement of the weight is using a spring balance or a compression balance. Property of the mass. Mass of an object cannot be changed by changing its location, shape, and speed. Whereas the property of the weight is, weight of an object may be different depending on the gravitational force of its location. An example is here. The following shows the mass and weight of an astronaut when he travels from Earth to Moon. On the Earth, mass is 84 kg. On Moon, mass is same, 84 kg. In outer space, again mass is same, 84 kg. Whereas the weight of the astronaut on Earth is 840 Newton. Multiply 84 with 10, that will be equal to 840. On the moon, this weight will reduce to 140 because the gravitational pull on the moon is 1.6. And in outer space, there is no gravitational pull, so weight is 0. Gravity of the Earth is about 10 Newton per kg on the Earth. Gravity of the moon is about 1/6 of the value of the Earth. And in outer space, no gravity in outer space, weightlessness. And other question is here. A can filled with sand is hung on a long string close to the surface of the Earth. This is the figure. An identical can is hung in the same way close to the surface of the moon. This is the figure. The cans are given a sideway push like this. Compared with the can hanging close to the Earth, the can close to the moon starts to move. C will be the answer with the same ease as it has the same mass. Mass is same on the Earth as on the moon. The ease of the motion depends on the inertia of the can, which in turn depends on the mass of the can. The next topic in the lecture is gravitational field and gravitational field strength. Gravitational field refers to the region surrounding the Earth where gravity is experienced. The strength of the gravitational field is the strongest on the surface of the Earth and gets weaker further away. Gravitational field strength. It is defined as gravitational force per unit mass represented by small g. Gravitational field strength is equal to weight over mass. Hence, weight will be equal to mass multiplied by gravitational field strength, that is W is equal to mg. Gravitational field strength small g on the surface of the Earth is 10 Newton per kg. This means that for every 1 kg mass, an object experiences a force of the 10 Newton due to gravitational pull. Here is a question. Two rubber balls of the same size are both dropped on the Earth and on the moon. One ball is solid and one is hollow. The approximate gravitational field strength on the Earth is 10 Newton per kg and on the moon is 1.6 Newton per kg. Which ball has the greatest force acting on it? Answer is C. Because type of the ball is solid, were dropped on the Earth. Explanation is the solid ball has the greater mass because it contains more matter. It also has larger weight as W is equal to mg. Both the solid and the hollow balls experience the same initial air resistance as they have the same surface area. The resultant force acting on the ball is the difference between the weight and the air resistance. That's why C has the greatest force acting on it. Another question is here. The gravitational field strength on the surface of the moon is 1.6 Newton per kg. Which values of the mass and weight are correct for an object placed on the moon's surface? So B will be the right answer, because if mass is 10, when this mass 10 will be multiplied by 1.6, weight will become 16. Here is the working. W is equal to mg, m is 10, g is 1.6, so W will be equal to 16. So 10 and 16 is the right answer. So B option is correct. So this was the lecture. Read it again very carefully and make your notes. Thank you so much.